Hello, hello. All right, guys. So this is question number 4, and now we're into sketching, which is should be the easy part, but it's also a part where a lot of people do make mistakes. Let's head right into it. Part A gives you some initial conditions and tells you to sketch them. So y0 equals 0. The first thing you do is you go to x and you go to y, which is right here, and you want to sketch it. And what you want to do is follow the slope. And so here you see it's pointing down here, pointing down like all this. So you want to just follow that. You see this looks like goes like this, and then here the slope is 0, so plateaus. And the same thing on this side. Excuse my shitty drawing. There you go, that's more like it. And same thing here, you see it goes, and that is, well, actually, we'll just go straight into it. So that's number 3, 0 and 1, and this is our 1 right here. So it goes the same thing, reaches my 1, and it comes down. All right, my 0.5, which is here, this is at x equals 0, which is x equals 0, and then y equals 0.5. This is just a straight line. And the reason being is because the slope is 0 there. And you can see the slope here, the slopes are 0. So the collection of these, also here, there's another 0. That's how you can find, we just solved also B, find all equilibrium solutions. And you can see when you find them is just whatever there's 0 is equilibrium. And so you can also say that at y0 and at x0 and at y, this is what 1.4, 1.3. This is all 0, but it's not the whole equation there is 0, and that is why it wouldn't be equilibrium solutions, because it's only at a specific point it's 0. And okay, so for 1.6, we'll go up here. This is 1.6, and this is a bit wider, takes longer to recover, but it does go up because it's only equilibrium at 1.5 exactly. And so 1.6 there is a very small slope that in the beginning you don't notice, but as you go out, it starts increasing and increasing and increasing. And so that solves our solutions here and our solutions here. Another way you can check, you can say your y prime equals x cos pi of y, and if you plug any number here, it would give you the exact slope that you're looking at. And so you see, if we plug in here x, or even like anywhere you see here, anywhere on x at x0, our y at the slope, regardless of y, is 0. And because when x at 0 here, when x is 0 multiplied by whatever this is, that will give you 0. And you see, this does, if you look at the equation, you want to confirm that this direction field does match it, you can just look straight at that, and that is that. And you can look at your y, and you can say when my y is 0, so you see when my y is 0 down here, multiplied by pi, that will give me cos of 0, which is 1, and now you'll have x equals 1, right? And then if you go to x at 1, and you see if I go to x at 1 right here, and I do 1 times 1, right? Because my y here was 0, and so if I do 1 times 1, that will give me a slope of 1. And you see when I go here, you see the slopes here are actually 1s, and so they're not 0s. And so you can you can do all sort of things like this to confirm directional fields with equations. And yeah, this was a short video.